We can use the law of sines to find the missing sides and angles of any triangle, not just a right triangle. We're going to know to use the law of sines as opposed to the law of cosines, which we'll look at in another video, when we have an angle-side pair. So in this case, I know both side B and angle B, so that's going to be my cue to use law of sines. So here's how law of sines works. I'm going to match up those corresponding side angle pairs and say the sine of 25 over its corresponding side, which has a length of 15, is equal to any other corresponding angle and side. So in this case, let's go ahead and find side C first, since I know angle C. So I'll match this up to sine of 107 over side C, which I don't know. So I'm going to solve this like I'd solve any old proportion by cross multiplying. So if I grab a calculator and make sure that I'm in degree mode because I'm measuring things in angles, when I cross multiply this way, I've got the sine of 25 times C. That rounds out to about 0.42. Round to usually 4 decimal places. I didn't round. It must come up 0, 0, I suppose, or maybe I was feeling lazy. When you cross multiply the other way, it's 15 times the sine of 107, which you could just type directly in your calculator like that. 15 times sine of 107. That came out to be about 14.34. Again, the more decimal places you can use, the more accurate your answer will be. In fact, I used the full number that comes up on my calculator. I'm just writing down what I had rounded. From there, solve like normal. So divide both sides by 0.42, and I'll find my first missing side. That comes out to be about 34.14. Let's go ahead and add that to the chart. Now, you don't have to use the chart, but I like to use the chart just to keep things a little bit more organized. Next up, I've got to find side A and angle A, and it seems like, well, I don't have an angle pair relationship, but remember, the angles of any triangle, not just a right triangle, will always add up to 180, so I guess I could have even started with this. Since I know 2 of the angles, I can subtract from 180 to find out that angle A is 48 degrees. So there's an answer. I like to circle the answers in my table, as opposed to just what they gave me. And now what I can do to find side A is, well, let's just do another proportion, another law of sines problem. So that angle B, side B relationship seemed to work really well, so let's do that one again. So once again, it's the sine of angle B over side B is equal to the sine of angle A, which I now know is 48 degrees, over side A. Okay, and we'll do the exact same thing. We'll solve this by cross multiplying and find out what side A is equal to. So once I cross multiply this way, again, I can use my calculator. I see, well, of course, it's going to come up with the same thing as it did last time. 0.42 times A is equal to, I'll do 15 times the sine of 48, making sure I'm in degree mode. That comes out to be about 11.15. And again, I would recommend don't round these off in your calculator, just use the full answer on your calculator. Finally, divide both sides by 0.42. And I find out that side A is approximately equal to 26.55. So let's go ahead and add that to the table as well so I can see that I've completed the table. Right there, so 26.55. So I've solved the triangle. I know all 3 sides. I know all 3 angles. One thing that I like to do just as a quick check is make sure, since we know biggest sides are across from biggest angles, make sure that's true in this case. So my biggest angle is 107. It's across from my biggest side, which was 34.14. And then smallest side and smallest angle should be across from each other. So it's a quick, easy way just to check and make sure you didn't make any mistakes in there, and there you go. That's how we can use law of sines to find the missing sides and angles of any triangle.